Today we're going to go ahead and review and take a look at some new properties of exponents. Now, a reminder, we're only going to be working with, as we look at this entire section, A is going to always be positive, B is always going to be positive, and then the X, Y, and N will always be real numbers. So they could be positive, they could be negative, they could be any type of numbers. Now, a reminder, what an exponential looks like. So b to the x power, where b is called our base, x is our exponent. Another way to write this is we could use b raised to the x power. We see that in some of our calculators. So we use the caret symbol sometimes to represent our raised to. So we can take a look at a couple different ideas. You've done this before. 2 to the third power. What does it mean? Well, a couple different ideas. It could mean 2 times 2 times 2, which is 8. That's one way to think about it. Or sometimes we might think about it as, well, 2 to the third power is the same thing as 1 times 2 to the third power. So that's 1 times 2 times 2 times 2. Well, 1 times 2 times 2 times 2 is still 8. Now, the second way is going to be helpful in defining some of our exponents down the road. That, okay, this 2 to the third power is just thinking about it as 1 times 2 3 times. So 1 times 2 raised to the third power. So we're going to be taking a look at the properties of exponents. You should have a handout with this. I'm going to go through some examples if you want to go ahead and write those down. I'm just going to kind of refresh our memory on those different exponents. The first property of exponents that we're going to take a look at is when we are multiplying like bases. So a is our base raised to the x power times a raised to the y power is the same thing as a raised to the x plus y power. So, for example, if we have a squared times a to the third, well, remember that is just a times a is a squared. A to the third is just a times a times a, and if we multiply them, we now have a times a times a times a times a. We have that 5 times. So a to the second times a to the third is a to the fifth power. Now if we put some numbers in for a, they have to be like bases. So 3 to the fourth times 3 to the third will be 3 to the 4 plus 3. So that will be 3 to the seventh power. So anytime you are multiplying like bases, you are going to add the exponents. Now, since this is an equal sign, this goes both ways. So if you have a to the 2 plus x, that is the same thing as a squared times a to the x power. So another way to write it, and realize that we're so used to going one way, we got to be able to go both ways with this. So a to the x times a to the y is a to the x plus y. So we can use that to simplify when we have like bases. Now when dividing like bases, very similar to when we did multiplying like bases. When we multiplied like bases, we added the exponents. When we divide like bases, we subtract the exponents. So a to the x divided by a to the y is a to the x minus y. So if we have a to the eighth over a to the fourth, that is a to the 8 minus 4, which is a to the fourth power. We could have 2 to the third over 2 to the fifth. So that's going to be 2 to the 3 minus 5, which is 2 to the negative second power. Now that might be something new for you to see with negative exponents. We're going to take a look at a rule that deals with negative exponents here down in rule number 6 and rule number 7. So again, remember this is an equal sign, so a to the x minus 3 is the same thing as a to the x over a to the third power. So that is our division by, with like bases, we're going to subtract the exponents. Okay, for the third law of exponents, we're going to take a to the x and raise it to the y power. Now if you take a power to a power, you're going to multiply the exponents. So a to the x raised to the y power is a to the xy. So if we take a to the fourth and raise it to the third power, if we think about that, a couple different ways we can write that. We could write it as a to the fourth times a to the fourth times a to the fourth. That would be like writing it out as our a to the fourth multiplied by itself 3 times. So now we have like bases, we could add our exponents, get us a to the 12th. Well, that can be kind of laborsome sometimes, so we have this shortcut, property number 3, which says, oh, this is a to the fourth times 3, so that is a to the 12th. So this property allows us to go ahead and use a little bit of a shortcut to answer this. Now, we should see that a to the third to the fourth power is going to be also a to the 12th. 3 times 4, same thing as 4 times 3, so we're going to get the same. If we take 2 to the 5th and raise it to the second power, that is 2 to the 5 times 2, which is 2 to the 10th power. So again, the rule is, raising a power to a power, you multiply the exponents. Okay, property number 4 says we're going to take a product, a times b, and raise it to the power. If we take a product, a times b, raised to a power, we're going to take each of the factors raised to that power. So that is a to the n times b to the n. So let's take a look at if we have a b raised to the third power, that would mean that we have a cubed times b cubed, whatever those might be. Well, that means that if we have 3a to the third power, each of the factors in that product get raised to the third power. So we get 3 to the third power times a to the third power. 3 to the third power is 3 times 3 times 3, which is 27a cubed. So if we have something like, okay, let's go 2xy raised to the fourth power, each of the factors gets raised to the fourth power. So 2 to the fourth, x to the fourth, y to the fourth. 2 to the fourth is 16, x to the fourth, y to the fourth would be my answer for that one there. Let's take a look at one more example. 3x squared y raised to the fourth power. So that means 3 gets raised to the fourth power. X squared gets raised to the fourth power. Y gets raised to the fourth power. 3 to the fourth power is 3 times 3 times 3 times 3, which is 81. X squared raised to the fourth power. Oh, we get to use property number 3. We have a power raised to a power. So that is x to the 8th, and then y to the fourth power. Property number 5, we take a look at a fraction raised to a power. So a over b raised to the n power is a to the n power over b to the n power. So the numerator gets raised to the power, the denominator b gets raised to the power also. So if we have 2/3 raised to the third power, 2 gets raised to the third power, 3 gets raised to the third power, 2 to the third power is going to be 8, 8 to the third power is going to be 27. So if we have a to the fourth over 2 to the fourth, that is going to be the same thing as, okay, they both have the same power, so we can rewrite them as something raised to the fourth power, that is a over 2 raised to the fourth power. So remember, that equal sign just means it goes both ways. We got to be able to see that, okay, a to the fourth over 2 to the fourth is the same thing as a over 2 raised to the fourth power. Sometimes we may ask you to simplify it and leave it like this, or sometimes we might actually try to figure out what is 2 to the fourth power. Okay, property number 6, we take a look at 1 over a is the same thing as a to the negative first. So now 1 over a is the reciprocal of a. So as we look at this property here, anytime we see a variable in the denominator or something in the denominator, it always has a power that is going to be negative. So 1 over 2 is the same thing as 2 to the negative first power. 1 over 6 is 6 to the negative 1 power, which means that 9 to the negative first power is 1 over 9. This is our reciprocal property. So if we want to take 4 and find its reciprocal, 4 to the negative 1 is 1/4. It's also going to help us use the property of our multiplication inverse. So we know 4 times 1/4 is just 1. So that means that 5 times 5 to the negative first must be 1 also. So now, this is 5 to the 1 power times 5 to the negative 1 power, which is, well, using like bases, add the exponents. That's going to be 5 to the like bases, add your exponents. 1 plus negative 1 is 0. So 5 to the 0 power is going to be the number 1. We're going to take a little bit more look at this part in property number 8. Okay, property 7 is related to property number 6, but this time we don't just have to be raised to the negative first power. We could be raised to any negative or any integer. So if we have 1 over 2 squared, that is 1 over 4, which is 4 to the negative first, or that would be the same thing as 2 to the negative second. So you could simplify. 2 squared is 4. 1 over 4. Okay, that's just the reciprocal of 4, so that's 4 to the negative first. Or 1 over 2 squared is the reciprocal of 2, is the same thing as 2 to the negative second. So let's take a look at another one. 3 over 2 to the fourth would be the same thing as 3 times 2 to the negative 4th power. If we want to leave our exponents, we could try to simplify 2 to the 4th power, come up with a fraction, but sometimes we can go ahead and leave it in exponential form. Leave our exponents. So that would just be 3 times 2 to the negative 4th power. Now, cannot combine those because they're not like bases. Remember, we can only combine if we have like bases. So let's take a look at another one here. Let's take a look at 3 to the negative 3rd power. That is going to be 1 over 3 to the 3rd power. Now we can leave it in that form there, or we can find out what 3 to the 3rd power is. Now, what happens if we start with, so let's take a look at this case here. If I have 1 over 3 to the negative 3rd power. Now, I have a negative exponent in the denominator. So intuitively we can go ahead and think of, well, we just said that 3 to the negative 3rd power is the same thing as 1 over 3 to the 3rd power. And that's just coming from right up here. 3 to the negative 3rd power is 1 over 3 to the 3rd power. Well, we have a fraction, a complex fraction here. So then we have the number 1 divided by a fraction. Well, remember, that's the same thing as multiplying by the reciprocal. So we end up with just 3 to the 3rd. So that's kind of a long way of doing that. So 1 over 3 to the negative 3rd power. Since the negative power is in the denominator, to make it positive, move it to the numerator. So we're just going to take this and move it up. And so that ends up giving us 3 to the 3rd power. So you have something raised to a negative exponent. To make it a positive exponent, just move it to the other part of the fraction. So property number 8 states that anything raised to the a raised to the 0 power is 1. And remember, we said a at the beginning had to be greater than 0. So if we take any positive number and raise it to the 0 power, it is going to be 1. Now we saw that that just kind of worked out when we did an example before, and why it works out is 5 times 1 over 5 is, well, anything times its reciprocal is 1. Now remember, we said that 1 over 5 is 5 to the negative 1 power. So, if we take 5, which is raised to the 1st power, times 5 to the negative 1st power, like bases, we add the exponents. So then it's with 5 plus a negative 1. So we end up with 5 to the 0 power has to be 1 to follow our rules. So it doesn't matter what positive number we raise to the 0 power, it is always going to be 1. Because it's using that idea of a number times its reciprocal is always 1. Now, property number 9, we go ahead and define the square root of a number as the number raised to the 1/2 power. So the square root of 4 is 4 to the 1/2 power. One way to think about that. So that we know the square root of 4 is going to be 2. So the square root of 3 is just 3 raised to the 1/2 power. Well, we don't know what the square root of 3 is, so we just leave it as written as an exponent, 3 to the 1/2 power. So the radical sign is a square root. That can be rewritten as the power 1/2. So the square root of 16 is 16 to the 1/2 power, which we know is going to be 4. So the square root of a number has an exponent of 1/2. Now most of you are familiar with square roots. And remember, square root is just a number times itself. That gives us another number. But we also have cube roots, fourth roots, fifth roots, and really any rational number can go in there. Excuse me. Any positive integer can be used to find a root. So we don't just have square roots. We have cube roots. We have fourth roots, fifth roots, 10th roots, 172nd roots if you want to try to find it. But some ones that you should know. The cube root of 8. Well, if we think about 8, 8 is 2 times 2 times 2. So that's a cube root of 2 cubed. Remember, a cube root and a cube would cancel each other out, giving us an answer of 2 for this. So the cube root of 8 is 2. The cube root of 27. Well, 27 is just 3 times 3 times 3. The cube root of 3 cubed, the cube root and the exponent are opposites of each other, so we end up with the cube root of 27 is 3. So the fourth root, fifth root work very similar with that. So if we want to find the fourth root of 81, well, that is just 81 to the 1/4 power. Another way to write it. Now, quite often we want you to simplify that if that's possible. Well, that fourth root of 81, 81 is 3 times 3 times 3 times 3, which is 3 to the 4th power. The fourth root and the 4th power cancel each other out, gives us 3. So the fourth root of 81 is going to be 3. Okay, property number 11, square root of AB. So A times B is a product. The square root of a product is equal to the square root of each of its factors. So the square root of 3A would be the square root of 3 times the square root of A. We don't know the square root of 3. We don't know the square root of A, so we can leave it just as is there. So let's take a look at the square root of 4A. Square root of 4 times the square root of A. Do you know the square root of 4? Yes, you do. You know it's 2. Do you know the square root of A? No, we do not. So my answer would be 2 times the square root of A. Let's take a look at the square root of 16B to the 4th. That would be the square root of 16 times the square root of b to the 4th. Square root of 16 is 4. Square root of b to the 4th is the square root of b squared times b squared. Well, that's going to be b times b, which is b squared. So the square root of 16b to the fourth is 4b squared. Okay, property number 12. We have the square root of a over b. We're going to see that we can break that up into a fraction, square root of a over the square root of b. And vice versa. If they're both taking the square roots, you can turn it into a single quotient, or you can break it up into a numerator and denominator. So the square root of 4b will be the square root of 4 over the square root of b. We know the square root of 4 is 2. We don't know the square root of b, so we'll leave it as 2 over the square root of b. If we have the square root of a to the sixth over 4, that would be the square root of a to the sixth over the square root of 4. Square root of a to the sixth is, remember, a to the sixth raised to the 1/2 power over square root of 4, you all know, is 2. Okay, we've got a power to power, so we multiply exponents. 6 times 1/2 is 3. So we get a cubed over 2. Okay, last property of exponents that I want to take a look at is the x root of a raised to a power of y. We're going to see that that is the same thing as taking the x root of a to the y power, or we can rewrite it as a raised to the y over x power. Now, just remember what we have here. Remember, x root of something. So the x root of a is a to the 1 over x. So if we take the x root of a and then raise it to the y power, that would be a to the 1 over x raised to the y power, which power to power, we multiply the exponents. We get a to the y over x. So that's one way to look at it. Again, if we look at the second form, here we have a to the y, and we're going to take the x roots. So that's a to the y raised to the 1 over x, which is just a to the y over x. So that's just a way to go ahead and rewrite that set there. So let's look at a little bit of simplification of those types of problems. So if I have the square root of 16 raised to the 4th power. Now, the square root of 16 is 4 raised to the 4th power. 4 to the 4th power. Oh no, I think this is going to be a fairly large number. So you might need your calculators. You might not. Some of you might know what it is. So 4 raised to the 4th power is 256. Now, another way we could have done that was taking the square root of 16 to the 4th power. Well, the square root of 16 to the 4th, 16 raised to the 4th power is a really big number, 65,536. And then if you take the square root of that, you still get 256. So it doesn't matter which order you do it in. Or you can make it a little bit easier if you don't like those numbers. It's like, okay, I had the square root of 16. Oops. Square root of 16 raised to the 4th power. Remember, oh, that's 16 to the 1/2 power raised to the 4th. Well, power to power, and we'll multiply the exponents. So 1/2 times 4 is 2. 16 squared is 256. So that might be even the easier way to go ahead and do that. But you're going to end up with the same answer no matter which way you do it. Did you take the root first, then raise it to a power, like we did in the first one? Square root of 16 was 4, raises the fourth power is 256. Or did you take the number to the power, 16 to the fourth power, 65,536, then take its square root, which is 256. That's a little bit bigger numbers. Or did you simplify your exponents by taking, oh, that's just the 1/2 times 4 is 2. 16 squared is 256. So those are our properties of exponents. You may need to refresh a couple of them. You can find more examples in section 6.1 and 6.2. And we'll be taking a look at those and applying those throughout the rest of algebra.